That's supposed to be in simple terms.
No. What have I used to answer it?
Unveiling formulas.
What techniques? Does anyone know what it is?
Derivatives.
It's a mathematics thing. Derivatives. It's actually, I've done separable differential equations. Alright? You know Newton's laws of motion, physicists. What are they? One of them says, the school one says, S equals ut plus half at squared. Alright? This is actually the derivation of that formula. Alright? Now you can use that. What basically it does, this thing here basically says the rate of change of velocity is the acceleration due to gravity. Because acceleration is the rate of change of velocity. Alright? You separate the differential equation and integrate, gives you that. That's an initial conditions where when he first drops it, what's its initial velocity? 0. At time t equals 0, velocity is 0. So that means it c is 0. So you reduce it to that. But v, velocity, is the rate of change of displacement. So v is ds dt. Another separable differential equation, and you will get the answer. There's an explanation. Where's that pitched at?
University.
Way higher than year 7, yes. Is it a valid explanation?
Yeah.
Yes. Perfectly valid.
Sure it is.
When we get to the end, what I will do is I will just use the video, use a stopwatch to time how long the thing drops, stick the t in down there, because the value of g is 9.82 or thereabouts. Stick the t in, and I can work out how far it will have dropped in the time from when he dropped it to when it went smash. And I will get a good estimate of that displacement. Alrighty? What I'm more interested in though now is what did you say? Did anyone come up with an explanation? Anybody? Who wants to?
I did.
Yep.
I said like real rough, as if I was pitching this like real young sort of kid, so not like math. Give or take, when you drop something because of gravity, it's going to fall roughly about 9 meters per second, not including like accelerating the further it drops.
Yep.
So I said, if you drop something and you count the number of seconds till you hear it hit, then you can work out that, okay, 1 second is going to be roughly 9 meters.
Fantastic. Good. It's not actually right, but what makes it fantastic is something else.
It gives an approximation.
It gives an approximation. What could you now do if someone in your class came up with that? What's the next thing you would do? Do you go, that's wrong, that's right?
Can anyone add to that?
Yeah, can anyone add to it?
Yeah.
So you take what they've given you, you've got a starting point of a reasonable explanation. Has anyone got anything else they can add into this to make it more accurate or more meaningful or more whatever, more valid?
I'd mentioned that the mass of the bottle contributes how fast it will fall and things like that.
Does the mass of the bottle contribute to how fast it
Not
falls?
that, no.
Come back to that one in a minute. Hold that thought. All right. Once you've sort of taken this initial idea and you've got people contributing to it, you notice there's no right or wrong answer at this stage. They're just going, oh, well, what might it be? What can it be? And you come up, and at the end of it, what will you have actually generated with your class? And something with an H. Hypothesis to explain what you saw. It's a prediction to explain it. What can you then do?
Test it.
Pardon?
Oh.
Test it.
Test it. Can you test it against this? Yes. Because when he drops it, your argument, your explanation will work reasonably well so long as the time of fall is approximately...
9 meters per second.
No. How long in time?
Not too long, 1 second.
1 second. As soon as it goes beyond 1 second, the accuracy of the model that's been proposed to explain it, what happens to it? It gets worse and worse. Because the velocity, look at that there, the distance it falls is equal to the acceleration of gravity times the time squared. If it was just time, it would still work. But it's not time. It's time squared. If you put 1 there, what's 1 squared? 1. So it works that the displacement comes up to the gravity. It will give you a reasonable explanation, but it's not actually just gravity. The problem is, it's at 1 second, the displacement is not 9.8. It is in fact 9.8. What's this bit here? Divided by 2. It's half of 9.8. So what you can do is take the model that's being proposed, and this is exactly what you want to happen in schools. You want kids to explain where their heads are. All right, if I just get up and do that, okay, kids, what I'm going to do now, and rather than doing it with some sort of stimulus, I just go, all right, we're going to drop something, and I'm going to show you how to come up with an equation, demonstrate and work out how far it's dropped based on time, and then I do that. How much will they know by the time I'm finished? Absolutely diddly squat. Even if they can do this, they probably won't really be able to connect it to the reality. What happens here, if I take the model that's been proposed, I can test that and demonstrate what's going to happen if we test this model.
We'll find the limitations of it.
We'll find the limitations of it. We can find that it works for 1 second or whatever, but then as it goes away from that, we find the model doesn't work, and then what do?
Suggest ways to improve it.
Make it improve the model. What's wrong with the equation? Or what's wrong with the way we've conceptualised what we have here, and get them, who proposes the modifications generally? What are you after as the teacher? Do you tell them? No. You want them to take the model and develop it over time. Does that make sense? Right. Everyone's happy with that? Good. So, when we talked about 5Es last week, what was step number 1? Engage. What was that? That's the engagement tool. What's an engagement tool? And I show the whole thing. I don't just show the bit I'm interested in. Because everyone, I love Big Bang Theory. I even brought my cup to demonstrate the fact that I do. There is so much you can use things like Big Bang for that it's really quite amazing. Now, to give you an example of another video, you have to pick your mark. This is a stimulus that I used last year for one of the mathematics units, the secondary Year 11 and 12 maths units.